So we have seen the electric field due to a uniformly charged infinitely long wire, and we saw that its direction is radially outward if charge on this wire is positive and radially inward if the charge on this wire is negative. And you can read some of these notes, some of the notes you can read, this will be helpful. So now let us come to the second application of Gauss law. Second application is the field due to a uniformly charged infinite plane sheet. So first case was simply a wire. Now we have taken a sheet infinitely long. So that means this, here you are seeing this much big piece of this sheet. It is not this. It is extending infinitely in z as well as y directions. Okay. So we have taken a small piece to solve this, but it is infinitely long in z and y directions. So first let us understand the diagram, then we will solve this. So here this sheet is given. This direction is y direction. Inside the plane, this is y direction. This direction is z and this direction is x direction. So first this is z, this is y and this is x direction. Let us understand the direction. In the next case, let us understand how the electric field works. So if there is a charge, so what we saw, for a point charge, it emits in all the direction radially outward in 3D. So that means this is coming in this direction as well as in this direction as well. Okay, so radially going outward. In the next case, what we saw is for a wire. So again it is radially outwards in all the direction. So electric field was in all the direction for a wire. Now we have to consider the case of a thin film or this sheet. Okay, infinitely plane sheet. So here it is this sheet. So for sheets, the electric field does not work like that. Electric field is like this always if this sheet is positively charged outwards. So it is not radially outward, it is perpendicular to the sheet or normal to the plane, or perpendicular to the plane. It is like in this direction. Okay, first understand this thing, otherwise it will be quite difficult for you to understand. So if we take any sheet, this is the sheet, so its electric field would not be in all the direction. Its electric field would be only in normal to this. Okay, normal to this, that's all. And similarly this side as well, this side as well. If it is positively charged, let us say if it is negatively charged, then inside, inwards, from both the sides, like this, inwards, that's all. Now let us understand this diagram and later we will solve. So since this sheet is infinite, so there would be no electric field in z direction, no electric field in y direction, because sheet is infinite in these two directions. There is no electric field in this direction, no electric field in this direction. Why? Because sheet is infinite in these directions. So the electric field would be only in x and minus x. So here it is E and the direction is in negative. Here it is in positive. So direction is in positive. So this is plus E, this is minus E, and other two direction there will be no electric field because sheet is infinite in these two direction y and z. The electric field will always be only in x and minus x directions only. So this is the figure. So this sheet is kept at x is equal to 0. this direction is positive x, this direction is negative x, this is positive x, and in y and z direction there would be no electric field because sheet is infinite. In those directions there is only charge, no electric field in those directions. Now how we will solve these? So we know that electric field is there in this direction as well as in this direction. Similar to last diagram, we will consider a Gaussian surface, In this case we are taking a very small part, of this sheet. Let us say this is a small part of this sheet, this is a rectangular part of this small sheet. Since this sheet is infinite, we take any small part of this small part, we extend this small part in x direction, we extend this part in minus x direction. So we came across with this kind of box kind of structure. If we extend a rectangle on positive x side as well as negative x direction, so we will come across this box type of structure, which is a parallelepiped. Now this area is A, and this is x, and this is again x. So this area is A, this is x, this is again x. So we took an area element A and we extend it to positive x direction as well as negative x direction. Now what we will see that this is the box type of structure, parallelepiped, and now as we can see that electric field is in this direction and the direction of normal to this surface is this. Direction of normal to this surface is in z direction. Similarly for lower one, so E dot delta S is 0 because cos theta is cos 90 degree 0. Similarly for this direction y and this y, it is also again 0 because 90 degree. Similarly for here, positive z, negative z, making 90 degree angle with this electric field, again 0. Y and positive y and negative y both again are making 90 degree angle, again 0. So the only element remaining, only surface remaining out of which flux is going out is this has a normal in this direction and electric field is also in this direction. Similarly here, electric field is in this direction, this face has a normal in this direction, and this is equal to A, this is A and this is A. So from left side and from right side there is flux going outward, and from rest of the surfaces like this downwards and backwards. So from these surfaces the total flux is 0. Flux is also 0. Only two surfaces are contributing in the emission of this flux, left surface and the right surface. Once you understood this thing, let us move. So now let us apply the Gauss law. Phi is equal to E dot delta S. So for other areas like this or this, E dot delta S is equal to 0. So for this, E is positive and delta S is A and that is also in positive. So E dot A, and for second one, let us add for second one, this is E in negative direction minus E dot, again area is also in negative direction, minus A dot minus A. So this minus cancel out. So EA and EA is equal to 2E dot A, and as we can say that both are in same direction, so this is simply 2E A, 0 cos theta.